Hi guys, so earlier today we had AtCoder beginner contest 189s. Um, I originally recorded the screencast, but I didn't talk much. And also Anand recorded the screencast today and did a post contest trip. So I actually think that he did a really good job in terms of both performing and explaining things. So I'll give just my short perspective on the contest instead. You can definitely watch his commentary or and his screencast. I'll put the link down into the description for both his YouTube and Twitch where he streams post-contest discussions because I found them like on this specific contest. I think that he clearly outperformed me both in standards and in explanations. We'll walk through my solutions anyway, because I guess that's why you're here. Let me quickly open tasks for printing. This should be somewhere here. And in terms of standards, I think I finished 88 for the second time in a row on ABC. It's kind of not bad because it's first 100, but it's not as great as Anand on the first page. Right. So I'm 88 and Anand is on the first page, which was kind of impressive. Problem E took me a long time to code because we'll talk about it later because he had very nice pre-written code. So that's something you definitely should think about. So problem A was about you playing slots for whatever reason. I don't advise it, but I guess it can be sometimes fun if you just, expect your money to be gone, and possibly then it can be fun. So we have 3 letters. We want to check that all of them are the same, right? What I did during the contest, I just checked that first is equal to second and second is equal to third. Of course, you can check like all 3 equalities explicitly, but the idea of transitivity, that's like if A equals B and B equals C, then A also equals C. It's kind of important. You can sometimes use it to reduce runtime complexity of your algorithms. So you got to learn how to use it. You can not only you can save time, you can also save complexity sometimes. So just as simple as you can make it. I guess like half of this is actually not necessary. Like this. Okay. Took me a while to submit. So as you can see, it's like 2 minutes, 54 seconds because like I had internet connections issues at the beginning and also immediately after the contest ended. For me, I also had connection issues, so I get very lucky like not to have them during most of the contest, but whatever, it happens. So problem B, I can't say much about this problem. You wanted to like, you had a limit of how much alcohol you can drink, or specifically Takahashi. You had several glasses with different like volumes and percentages. And the main issue with that problem was that you wanted to multiply limit instead and measure in persons of milliliters instead of actual milliliters, because otherwise you could end up with precision issues. I've seen a lot of people like getting wrong answers on this problem because of precision issues. I guess like here you would have to compare with something like absolute value of difference is at most 10 to the minus third, something like that. But it was not necessarily like it's always better to work without floating point numbers, so that's why I did it. And I also have like 2 redundant variables. Basically, you can get away without them. Tennyson, like whether or not Takahashi got drunk already. But I decided like to be very explicit in this problem, and also I changed variable names. So in the actual contest, you can check my submissions; they were different. Basically, nothing is readable on the contest submission, but like here, I made everything clear so that you can read the submission and basically understand what we are doing. Problem C. Honestly, I just copied my submission from LeetCode because I immediately recognized this problem. It took me a while to actually copy it because LeetCode, again, internet connection was slow, so I spent 2 unnecessary minutes loading my LeetCode submissions. But at the same time, I was implementing D, so I kind of got away with it without much time lost. Something like that. So yeah, I just copied off one solution from LeetCode. It's like largest rectangle in histogram. It's a visual representation of that problem. And there are also other ways to do it. And because of constraints, you could use like sparse table to like pre-processing would take a linear time, and then you'll have like quadratic number of intervals. You want to find minimum on each of them. So yeah, that's possible with sparse table. It's also possible with some like intended solution with such constraints was that you loop through starting positions and you just maintain the minimum on the intervals that goes to the right. So you will get away like with straight away with quadratic time. So yeah, but I had it pre-written and like, I'm not sure why they gave this problem. Potentially they wanted to trick actually more experienced participants. Excuse. Yeah, it's a bit annoying. I got a bit cold, not coronavirus or anything like that, because I'm sneezing, right? Instead of like, you got that, yeah. But it's a bit annoying. I'm not sure actually how I got it. Anyways, maybe they wanted to trick like more experienced participants because constraints are low. So that more experienced participants would immediately recognize the problem and like implement optimal solution, spending more time instead of implementing like straightforward solutions that passes for all constraints. But because I did not implement anything, I just copied. So I think I can't get away with it. And I was reading like the next problem straight away. So I didn't waste time like waiting for my submission to load. Something like that. I'm not sure that you will actually like face many problems that you've seen already anywhere except for like Div3 contests on Codeforces or beginner contests on AtCoder. But yeah, sometimes it helps even to that extent that you can just copy your submission. Problem D was kind of weirdly formulated with this and or signs, but actually, like what I implemented on the actual contest was a bit different, but I clarified a bit what I wanted. So we have a dynamic programming. Basically, they give you like, you want to count number of sequences that satisfy some condition at the very end, and they combine into another, one sequence combines into another sequence via operations that you're given. So I decided not to think about this problem and just like for every prefix compute how many sequences with which value of yi there are, because clearly like this condition does not depend on previous x y minus 1 or anything. So it's kind of assigns it if your future information depends on only on the current information, only on the current state, let's put it this way, then it's DP. Obviously, we can simplify to one of one space, constant space, because you only work with 2 layers. And like C++ and Python, I believe you can have very nice syntax where like, you encode entries of the previous false and true instead of 0 and 1. It becomes like much clearer what is actually happening. And you can also loop like this in Python, I believe. Like it's for current y in tuple of false and true. I find it like very nice. But yeah, if you think for a little bit longer, you can like find a specific representation of your value. In terms of sum of some powers of 2, you can watch. We can watch Anand and his solution. I find it very cool. I'll definitely put links down in the description. He did a really good job today, both explaining things and performing in the contest. So yeah, definitely check his videos out. Number. Yeah, but I just wanted to show that like this trick, if you want more semantics in your code, because it's like the more semantical meaningful your code is, the harder it is to make mistakes. So since like k end, definitely did not borrow it from Anand. Just kidding. Yeah, it's a really great idea to encode strings like constants, because then if you mistype something, it won't compile. Yeah. I mean, I'm just giving you a short recap of what Anand said, in case you don't want to watch like entire video. Just going a bit quicker through the problems. Yeah, something like that took me a while to implement, because I originally thought that we need current x, but we did not. So yeah. Anyways, next problem was kind of hard. We had a bunch of points on two-dimensional plane. We wanted to rotate them clockwise, counterclockwise, reflect horizontally and reflect vertically. Here you again can like make use of constants and then use them in your code, so it becomes like semantically clear and you never make an error. If you mistype something, it just don't compile. Yeah, very nice usage of constants. I did it actually the awful way around. So first of all, no, actually like defining structures for everything was a good idea. Because then I had meaningful names again, instead of like first, which sometimes happens. I had, yeah, actually since this is a position. Yeah, I wanted to change it, but yeah. So yeah, here we are just reading input. Then like usual trick when you want to process squares is, well, first of all, you want to add query ID, so the index in input, then you want to sort them. And in this case, you wanted to sort them based on operation ID. So first, you wanted to process queries that have like the lowest operation ID, something like that. Because it makes sense to process operations and queries in order, I guess it's like not the only problem where something like this helps. Okay. And then I basically had like four terrible global variables that maintain some information about the global state of points. So basically, I realized that these operations, values, like you can have, when you reflect, it corresponds to some like shift, global shift, everything shifts by some vector. And when you rotate, like X and Y coordinates can change places, and also some of them can get negative. So I made a very stupid decision of encoding everything like that. So if value of X state is 1, it means that current X coordinate is equal to original X coordinate. If it's -1, it means that current X coordinate is equal to minus original X coordinate, etc. for Y states. So minus corresponds to negative, 1 to X, 2 to Y. And like this part is standard. I mean like this sync is standard, while operation ID, like Y moment and time for which you want to like find out the answer is greater than the current operation, you have to process the operation. And processing operations corresponding to rotating the other way around, and shifting some things. So yeah, something like that. And then you wanted to restore answers of like X and Y coordinate, and I just did like this way. I don't know, I just realized, at the moment I realized that all operations can be encoded in several global variables, I just decided not to sync and just to implement. So I draw several pictures, drew actually, yeah, let me start. So I was writing something like this. As you can see, probably you can't see because it's a widow settings. Yeah, something like that you should see. So yeah, basically I was just figuring out, actually that was not the problem, something like that. So I just figured out like that signs change, and at that point I stopped syncing, jumped into implementation. Anand has really cool solution with 3x3 matrices and operations with them, but I did not have them pre-written. So like for me, the fastest way to implement that problem was something like that. Yeah, but definitely check out his stream if you want to find out how to do it with matrices, because it's really cool. I even think that I like should pre-write the same matrix operations for myself, because it just overpowered in this problem. With operations, you can cut them much better. I mean, it's kind of not long still what I implemented, but it was really annoying. Like here, I actually mistyped. I initially just copied that part, and px got here as well. I changed y here, but not px here. And it led to me like spending several extra minutes for debug. So by the time I submitted E, Anand was already done. Something like that, unfortunately. For problem F, it's actually a very nice problem. So here we want to go like from position 1 to position n or past it. We randomly go from 1 to n squares forward. And there are several dense squares or positions at which you basically restart. And I did it with DP of the following kind. I actually calculated moves to victory and probability of restart for each position from the last to the first. And like originally I was stuck at that problem. Like if for first 4, I immediately realized what I want to do. For 5th, I kind of realized that we had global state and we want to recompute it efficiently. For this problem, I just I got stuck at the beginning, so I would like to guide you basically through the syncing process, because it's kind of important. So at first, like I'm actually a big fan of like psychological things that you can get out of the problem statement. So here I noticed like not a small number of bend positions or restart positions. And I wanted to use it. So at first I decided like, oh, maybe K is some parameter in DP or something like that. So I decided like, what will happen if we had no restricted positions? I realized that I still can't solve the problem. So I wanted to use linearity of expectation, but it definitely not something that would help. And then I decided like, what is a position like for which I know the victory? And I realized that it's the last position. So approximately at that point, like 10 seconds later, I realized that I definitely want to compute from the end to the start, no matter what happens like with K. So I already typed something like deep vector dp, something like that, and filled last values. And here we can, like, this is an important implementation detail. It's I allocate plus m moves positions because you can go past last position. So without it, you get a runtime error. And then I wanted to see like what happens, like what actually happens when we have like here is position m. We know that here expected number of moves to win is 0. Okay, what is the expected number of moves here? Like it's 1. But why is it 1? It's 1 because we can jump anywhere into like from this point to n plus m, and the average answer here is 0, right? That's why we have 1 here. And then I thought like, okay, what's the next move? And next move is the average of next m numbers. So I realized that I want average. I want to maintain average on the sliding window of width m. And if I don't have like blocked numbers, then I just then my answer at AI equals 1 plus average on I plus 1, I plus m, AI. So clearly you can maintain this with the sliding window. And it's also better to maintain some to avoid some precision issues. I mean, after problem B, we already understand that it's better to avoid precision issues. And then I thought, like, what happens if actually the cell is blocked? And I realized that if cell is blocked, so block, and here you have no block, and answer at position I is basically answer at position 0, right? Because you return to the beginning. And then I thought like, oh, it's great, right? But then you realize that what actually happens here. You have a 1 out of m probability of returning to the beginning. So like I minus 1 is now 1 over m a0, and a0 plus 1, I think. But plus 1 we can add like general as a, and then you have like whatever is the average here on the next m places. So that average is still here. And then you realize that all that appears in your formulas, like even if you have another blocked position, then like just this counter increases. And you realize that everything is a linear combination of some numbers that you already computed when going from the end to the beginning, and the first number. So it's a linear combination. Now, and then when you get to the very beginning, you get something like A0 equals, wait, okay. 0 equals some probability times A0, probability of restart, plus some number like expected number of moves. If it's a linear equation, you get like A0 equals expected number of moves over 1 minus b. With several exceptions, like you got to be careful when the answer is -1, when it's impossible to reach, and it's only impossible to reach when you have m blocked cells in strict succession. Because like if you don't have m blocked cells, you just have like, if every m cells have at least one free cell, then you can jump here with some luck, right? But some luck means the probability of winning is non-zero and you can jump out. So yeah, if you don't have m cells consecutive block, then you can win. Even with a huge number of moves, right? So I initially used an incorrect condition for that. I initially checked that it's like, oh, this condition must hold all the time. It's like how many positions we restart from. Actually, it's not average restart. It's like, it's actually a count restart. If count of positions at which we restart is at least moves count, then we fail. And I only checked this condition at the very end, and it's not correct because you want to, like, this m blocked cells in a row can be somewhere in the middle. So yeah, I originally checked it here and got a penalty of 5 minutes, fortunately. I don't think it would change a lot. So, oh, okay, it just lags a little bit. Okay. I don't think it would change a lot, like 63 minutes. (6301) would take me like to place number 71. But yeah, so the difference is not great, but yeah, it happens. Like a lot of people had wrong submissions. So I guess it's kind of fair. At least we learned something new now, right? And this is also not average, it is like, it's the sum. Then we divide it by moves count. Yeah, I wanted to like only have floating point here. Yeah, actually my entire internet is a bit laggy today, so it's really annoying to record anything because, yeah, whatever, never mind, it's okay, it happens. So yeah, you just compute moves to victory and probability of restart.